As usual, this class is being recorded. But heads up, I am recording this lecture. It'll go on Zoom, and that's why you have this. I look like one of my daughter's friends, like teenage high school student with one AirPod in, because I've been told the audio doesn't work too well when I walk around the room, and I like to walk around the room. So this is my microphone. So I can hear you, believe it or not. So this should be hopefully pretty good. Hopefully the audio quality will be good online as well too. Welcome to a new semester. Welcome to spring 2025. What a mess today is weather-wise, surprisingly. It's great to be back. It's great to have missing data as a class. I'm excited to teach this class. I haven't actually taught a full class on missing data in my life before, but I taught snippets here or there, and I thought it would be nice to try to give you this as an instruction because I think it's sort of needed in a lot of what we do. So have my agenda up here. It's going to be a relatively brief class today. We're going to cover the syllabus and talk about the expectations for what we're going to be doing. I hope I warned you properly online about that. In full disclosure, I will be leaving shortly after this. I have a funeral to attend, distant relative. So I will be traveling after this class. So that's part of the reason why it worked out the way it did. It was not fully intentional, but that's unfortunately the way it goes. The other thing I will note is I acquired a new injury this winter. So those of you, I do not recommend slipping and falling. Although I will say this left side. I don't know if many of you know me from a couple years ago. A year and a half ago, I broke a bone. Also had a cast that was like an 8-week cast and 4 weeks of soft cast. That was the bone right next to the one I broke. That was a scaphoid. This is a distal radius. Much easier, like because I have my thumb, but still kind of a pain to type and whatever else. So not painful, but more of a pain figuratively, not literally. So don't slip on ice. That's my moral for you. Moral of the story. Um, so I know we all hate introductions, and actually most of you know each other, but just in case, brief introduction. Sound okay? All right. And I don't know, to make it fun, say something that you'd like to say briefly that's true about yourself and something that's an exaggeration or completely false that sounds really good. Okay? That sound good? My son's teachers do this, and it seems to work really well. I'll start. How's that sound? You know me. I think all of you know me. Um, True about myself. This is the end of my 19th year as a faculty member. Can you believe that? Yeah, I'm getting up in age, as you can tell. My body's failing left and right, but otherwise, in good spirits. The other thing I will say about myself is this winter I got to hang out with Taylor Swift in her box at the Kansas City Chiefs game. That was a lot of fun. It was, it's a different experience when you work with that. But she had a need for missing data, so wanted to talk to me about it. So it was kind of fun. So I think you can tell which one's true and false. How's that sound? And now what I'm going to do is I'm going to pause the recording so no one hears you, and we'll go around the room and go from there. How's that sound? I think it's recording. And once again, I'm Jonathan. Please call me Jonathan. Those of you who know me, those of you who don't, which probably is just you, Kendra. For those of you, I mentioned this before. Every time I teach, I try to record the lecture, make a recording of it. It goes on YouTube. This earpiece is my audio. That's why I have it there, but I can hear you just fine. I try to keep your voices off. I may end up saying your name when I point at you. If that bothers you, I could just point just to make sure. I want to make sure we're legitimate with FERPA and your privacy is respected. The reason why it's on YouTube, I found, is that if you're here, you can make the decision to not furiously take notes when I'm talking. You can go back. There's a transcript. You can search it. You can find what we're doing. So that's me. Let's talk about missing data for a little bit. Why do we need to worry about missing data? Anybody want to talk about that? Any examples of missing data? I got a couple examples. Let me give you a couple that stand out in my mind, right? This is not related to maybe statistical methods that you've taken in our program, or at least the ones I teach, but just broadly, right? This morning is an example. Up to a couple days ago, so I'm a little bit of a weather nerd. Those of you know that about me. And if you go to the National Weather Service, they have something called here, I even have it as a bookmark. Where'd it go? Right here. The scientific discussion of your weather. Yes, I read this every day. I know it sounds ridiculous, but this is like with my coffee in the morning. What's going on in the weather today? And up until Monday, each of the weather models except for one had no probability of snow today. And only that one had only a small probability. And so I looked at it Monday, and I guess I didn't really look at it yesterday. Well, yeah, no big deal. Happened to be flying today, checking to see what's going on with the weather, kind of usual. Turns out weather is really difficult to forecast, as you might imagine, not just because of all the dynamics, but because of missing data. We don't have observations of all the data we have, right? We have these great weather models that rely upon atmospheric data. What's collecting that atmospheric data? Right? We have surface observations everywhere. That's about 6 feet off the ground most of the time, right? We can talk about 2 meter surface observations, but that doesn't tell you the dynamics of the atmosphere that cause the weather, right? Sure enough, we do have weather satellites, but that only captures partial data. And on top of that, we have aircraft that will fly, and aircraft will get reading. But how often are you in the part of the atmosphere where winter weather is happening? Well, it turns out not very, particularly in commercial aviation that flies at 30,000 to 40,000 feet above the surface, right? Up there, there is weather, but it's the result of weather that's below that. Finally, there's a network of National Weather Service offices, thankfully, still in operation, hopefully still permanently in operation. We have one, ours is the local one is in the Quad Cities in Davenport, right? Every day, twice a day, they release a weather balloon, literally a balloon that has radio equipment, weather equipment on it, measuring temperature, wind speed, and pressure twice a day. That's your data. There's some, I don't know how many offices, 50 to 100. I don't know the specifics, right? Each one of those offices releases a balloon twice a day. There's your weather data. Guess what, though? There's a whole lot of data in the atmosphere that isn't there. The Earth is quite big. 50 balloons twice a day, not going to tell you a whole lot. So you may see in weather forecasting, particularly winter forecasting, we talk about having the potential for having a snowstorm a week in advance. We'll say, hey, look, models are picking up that there's a signal that there might be something. But if you read that scientific discussion, they'll even say, we can't tell a whole lot yet because the storm itself is over the ocean and we have very few observations from it. And as soon as it gets closer to land, our weather network will start picking up. And it turns out, as you've seen, if you follow hurricane coverage, we have aircraft that fly into hurricane, drop radio sondes, whatever those little tubes that go out the, like literally taking flight measurements at different altitudes. The hurricane hunters, they're called. That's because we need data. We need observe data to be able to model and forecast the storms better. And so, to me, missing data, you can see it right away. Today's snowstorm, not well predicted, sort of hinted at in the weather data, but not well predicted. And I think part of that is missing data. So you can guess what happens if you have missing data. It can possibly change your outcome, right? Did anybody expect to see this morning? No. Second, another reason for missing data. I try not to make this a politically sensitive class, so I'm not going to talk about politics. I'm going to talk about political polling, though, right? Particularly in 2016 and in 2020. In 2016 in particular, 2016 presidential election here in the United States was between Hillary Clinton and Donald Trump. And forecast polling observations had, I believe, about 75% chance that Hillary Clinton would win that election. Now, still not 100%, but you'd say if you're going to take a bet that you willingly put money on a 75% chance, maybe not a lot of money. Please don't bet, by the way. Don't do that. Sorry. The odds are never in your favor. You're gambling on variance, not on the mean. But that being said, polling error in that election happened because we have, well, first of all, when you have, how many of you have replied to a political survey in the last year? All right. How many of you have been asked to reply to a political survey in the last year? I know I have. I didn't. I had non-response, right? So non-response is missing data. Missing data in that election, there was quite a bit of polling error. And how that missing data were quote unquote handled, that seems to be the word that goes with. We handle missing data, which sounds a little weird. Like, oh yeah, a handle of a pot or something like that. How we manage it relies upon a heavy dose of assumptions that cannot be verified, right? And polling error since 2016, there were, midterm elections that were sort of a little bit off here or there. Things have gotten a little bit better because the assumptions are getting a little bit more accurate somehow. But still, polling error was quite large and is quite a concern. I mean, this election cycle, right before the election in November, there was a pollster here in Iowa, Ann Seltzer is her name, a very respected person who put out a poll that was very far off from the final result for Iowa, right? It was Kamala Harris was leading by 4 points. I believe Kamala Harris lost by 10 or 11 points, something along those lines. And part of the methodology that she used, if you look, she publishes, she's transparent about everything, doesn't follow the same assumptions that some of the other polling agencies used because of certain non-response. How do you weight non-response? How do you, for the people who replied, how do you see if they fit like the general population who's going to vote? So those are two big examples of missing data that can throw off conclusions that are everyday. Now, what do you think it does in your scientific data? Right? You have missing data in a data set. How many of you have had missing data? Better yet, how many of you have never had missing data? Raise your hand proudly. Thank you, James. The rest of us, I was going to say, missing data can provide problems in your analysis. Problems in which way? You may not get the right point estimates. You all evidently were doing statistics. We'll have statistical models. You have missing data in statistics. Your model estimates may be wrong. So what's a model? Think of a simple linear regression model, right? Predicting y with x. You have missing data on x. If you have non-response, depending on what type of missing data you have, and good luck figuring out which type you have, you may completely miss what the trend is in the data, right? Particularly if that non-response has something to do with both X and Y, right? If only people at the high level of Y don't reply, something along those lines, or at the low level of Y, you can imagine you'll be in trouble because you have to figure out what that works like. So to me, missing data and how we solve it is paramount in statistics. And the methods for missing data are quite elaborate, quite extensive. And much of what we're going to talk about in this class are pretty straightforward, but we want to talk about sort of the key. I'm just going to give you a brief sense of the key. If you have, let's say, hang on here, flip over to that. You can see that. All right. So we have y equals beta 0 plus beta 1 x plus error. That's a simple linear regression. And here, oh, it's trying to give me a nice equation. If you think about it, if we see x, and let's say some observation has, I don't know, I'm just making up numbers, 10 for y, and then x is NA, not observed, not available, right? The goal in missing data is to recognize we'll never know what x will be, right? And this sort of fits in, many of you took a class I taught last semester, Bayesian statistics, where and I think a lot about Bayesian statistics involves the quantification of uncertainty, right? Our posterior distribution talks about sort of an updated belief of a parameter. Well, in our case, the trick to missing data is to put in values for x or to treat the data in certain ways such that you recognize that you'll never know what x needs to be. So if we were to take this x observation here, this one specific cell, and we were to draw some type of distribution around it, we would think, okay, certainly it's more likely that x is somewhere from the center, but it's quite plausible that x could be somewhere here on an extreme value over here, over here. And that's going to cause a problem with our analyses, right? Moreover, how you try to make guesses about x will impact your results, right? So if you say, oh, yeah, I'm just going to, include x, I'm going to use something called full information maximum likelihood because that seems to be pretty standard, seems to work. That's great. But potentially, if X somehow, if this missing, it may not be enough, right? You may have to do something where we might need to basically plug in multiple values of X and do multiple analyses, trying out X's. That's actually what the weather service does. You ever see hurricane coverage where they talk about the spaghetti plot, the spaghetti models, the spaghetti lines? They have all these lines of potential models of where the tracks of storms might go. That's a different initializations about atmospheric conditions causing that, imputing missing data. Literally, the word we call it is imputation, right? So we have to make sure we find a way to put X back together that recognizes how much we don't know about it to allow an analysis to continue, right? We'll never know what X is. We'll never know what a missing data piece is. So that's sort of what the goal of the class is. That sound good? Sure. You signed up. So my goal is to get you to come to class number 2, right? Okay. Questions about any of this? Anybody have any stories about missing data they want to share? Hmm. Got rid of the data. Omission. Yeah, absolutely. That's common. Hmm. That's right. Imputing with the mean just gives one value for X, not the distribution, right? Yep. Right. Yeah. I mean, especially if there's some reason for the missing data, if there's a particular reason, right? If you're asking sensitive questions that people who might not want to share that answer to you with you, although it may not be the case in every survey, but that's sort of the worry, right? You never know. But yeah, omission is very common. In fact, a couple of years ago, I was part of a group here who were using autoencoders, this sort of machine learning architecture, to estimate multidimensional IRT models, right? So if you don't know what multidimensional IRT, just know there's latent variable models, multiple in one spot. These methods, weren't quite, I think the word is production ready at the time, still are sort of hard to map on. And where they're at now is saying, wait a minute, missing data. How do we handle missing data? Because we have to have complete data to use the architecture, at least the ones that they were using at the time. So for the same reason, we just omit it, right? That's where it goes. The end. Actually, it wouldn't even be this. This scenario is where you take a given value of X and include it. Omitting it would just be like, nope, this is not an observation in my data set at all. Yeah. Yeah. And so if you had any missing response, they were removed? Yeah, absolutely. That's a common method. Yep. And that's right. That's right. Missing data is that's a common method for it. In fact, like I mentioned, it's very common in a lot of well, and I don't claim to be an expert on machine learning algorithms, but a few I've worked with, and the ones I've worked with are very strict about not having missing data. So you can imagine though, if our AI overlords, which really, as I've been trying to tell my kid, it's not really I right now. I mean, it's like artificial dumb. I mean, a lot of it's pretty dumb. I mean, it's pretty cool. Like you can generate text and stuff. That's fine. But like when it comes to like making decisions about stuff, some of it works. But let's not get carried away, right? Kind of dumb. Part of that dumbness is related to missing data. How's that sound? Anybody else have any missing data stories they want to share? Yeah. Hmm. Yes. Computerized adaptive assessment will be like that. Yes. Right. Yes. And actually, it's interesting you say that because when we talk about what we're going to follow along, and I'll get to the syllabus in just a bit, I can come here and talk, right? I can stand. I'd rather stand in the middle. I don't like to be in the corner. The assessment data is interesting. Um, so computerized adaptive assessment, once again, I'll summarize it really quickly. You've all probably taken a computerized adaptive assessment. When you answer an item, if you get it right, it moves your ability estimate up, so you get harder questions. If you get it wrong, it moves it down. It tries to shorten the length of the test because it tries to pinpoint a question to where you'll have a little bit of difficulty answering, right? So where we think we have the most information about you in a mathematical sense, but also in a figurative sense. Yes, missing data there is a problem. In fact, one of the papers on a reading list shows what happens in cat data and the bias that happens if you analyze it as if it weren't missing, right? And that's not in classification sense, that's just in a general sense. Moreover, let's think of it this way. One of the more common, I'll put this in quotes, even though I don't know that it's really needs it, but I'll say it. Validity studies for an assessment. Let's think we're here at University of Iowa. We admit students. Many of those students take the ACT to come to the University of Iowa. Since the ACT was founded here, moved down the street, and now has evaporated into the remote work. So often we want to see what is the impact of ACT on, let's say, how well does ACT predict, let's say, first year GPA in an undergraduate sense? Now, you know of missing data, the sum of the missing data in that setup, right? You've heard of the missing data before that says, well, there are a bunch of people who didn't get in or chose not to come here. So they're not going to have a first year GPA. So that's missing. That's bad, right? Yes. We know the impact of it, right? It attenuates the correlation or attenuates the relationship between the two, usually, right? Because you have sort of a selected response. There's a bigger one, though. Think of the ACT score, right? I didn't take ACT. I was on the left coast, and that was where I took the SAT, but it doesn't matter. My score was pretty terrible. Um, do you just put that into if you had all the data, do you just put that in as a single number? Or does that score actually represent the most likely case from a distribution of scores? You see what I'm saying? Right? It's not your height. And if you believe what we teach in this program about test theory and psychometrics and measurement, that score represents our best guess as to what you might have on the construct that the ACT purports to measure. However, there's error to each score. Do you ignore the error? Better yet, I'm going to put a bold conjecture out there, and this is actually the latter half of the class. We're going to talk about missing data in psychometrics. I'm going to say this: there is no score, right? You think of the construct that we're trying to measure. Each one of us is supposed to be at some point on. Let's just assume, for the sake of argument, it exists. It's able to be measured, but not precisely, right? So ACT, your ACT score, we're trying to locate you on some continuum. We assess you with a set of items. We get a score. We get a conditional standard error around your score. We can think of a distribution around that score, right? If we're using maximum likelihood, we might call that sort of a limiting distribution. If we're using Bayesian methods, we might call it a posterior distribution. But those of you who've taken Bayesian before, you know that the mean is just one summary of that distribution, the EAP estimate, or the mode, the MAP estimate. But that distribution is the thing that matters. And so what I'm going to argue with in this class is that even when you sum up items from a simple survey, you actually don't have, the score is missing. It's a missing piece of data, right? And that you have to think of ways to go and model that so that it is not missing as you go forward. That still doesn't get you away from the attenuation problem, but it certainly causes problems from measurement error itself. Does that make sense? Ever thought of it that way? Yeah. Yes. Yeah. I think missing data is how much missing data you have will impact. If you have very little, it should have little impact. If you have a lot, it's going to be a whole lot of impact. Yes. And I think that's part of it, right? But the key in this class and what we're trying to do is to understand what ramifications happen to be. I don't know of a single case. I don't know where the line is where there's just, I have 10% missing. Is it 5% missing? Right? Each one of those potentially has the impact that could cause problems with analysis. And problems being biased in parameters, biased in standard errors, bias, potential type 1 error problems, maybe even type 2 error problems. Did that help a little bit? So yeah, there. That's me. That's what I'm saying with missing data. Why it matters. I always think of test scores as missing. When I used to work at a different university, actually, my first job was at University of Kansas. I was in the psych department, and there, the faculty were called in to advise undergraduates. And I had a few. I had to have a set number of hours. Random students I'd never met before I was teaching graduate students. Never met them. They walk in the door. Here's my test score. I'm like, yeah, like trying to go to grad school. Here's my GRE score. Not maybe it wasn't the best. I'm like, here's an argument for you. Argue with the principle of how much error there is in that score and where the range really happens to be. And that'll show you that you know enough about that. They'll be like, that'll just forget the test score and say, I know the properties of it. And that didn't seem to go very well, but that's always been with me with that as well too. All right. Other thoughts or questions on missing data? No. Good. Don't think about it. Let me be real. My name is Jonathan, and I've modeled missing data badly. I've done it before, right? In fact, I've omitted cases. Hold on. Back in the 90s, I know way back before many of you were born, we used to have like software programs like SPSS way back in the day had a missing data button, and its default was mean imputation. So I've done that, right? It turns out as we get into what we're going to do in this class, all of those methods are relegated to one section of the first chapter, which is kind of funny. And we'll talk about them next week in lecture. But those, we'll see kind of the impact of why we don't want to do that. The previous version of this book that we're going to be using, the first edition, had like more page space to it. And I like how the author, Craig Enders, has sort of shortened it down. And it's like, yeah, don't do that. Here's why. Good. That's good. So let's dive in. Shall we get into sort of course structure, syllabus, things like that, expectations? Please stop me if you have questions. I have no problem answering them. And as I like to try to say to every one of you, I respect all questions. My goal is to make you feel respected in asking your questions. If you have a question, it's likely one of your peers also does. I know how hard it is to sort of be vulnerable and ask a question, but I do appreciate it if you do ask. And if that's not good enough, you don't want to ask in class, you're certainly welcome to find me either during office hours or over email after class, whenever. I'm happy to answer it privately as well, too. Okay? Okay. So most of the class will be using the Applied Missing Data Analysis book by Craig Enders. Our university library is awesome. And I wrote them a note last fall knowing I was going to use this book. And I said, is there any way you could get this through an ebook? And yes, the answer was yes. Here it is, 5 minutes later. Seriously. Awesome place. The link is there. If you're a university student, you can get to it offline. You have to use one of the ebook software to read it, but it doesn't cost you anything. So if you like the book, certainly consider purchasing it, but you don't even have to do that. See how it works in this class and decide on your own. So you can find so I'm Jonathan, you know me, my email, my name, my Jonathan-Templin@uiowa.edu. The hard part is spelling my first name because evidently Jonathans have many spellings, but there's only one right way, and that's the right way right there, Jonathan. Our course website is right here. You know that, it's the same page. I also have a course repository for GitHub where I'll have source code and whatever else. You're welcome to download it. You don't have to be an expert with GitHub to find it. You can go to this code button, click on download zip. It'll be a zip folder. I'm guessing most of you have had experience with GitHub, at least a little bit, to get the repository. Those of you who have seen me teach before, you know that I do record. I mentioned this beginning. I do record my lectures. After class, I will have them uploaded to YouTube. Today's lecture will probably get there tomorrow because of my travel. And so there will be a playlist right here on YouTube, and you will also see a link to the lecture later on the course schedule in a little bit lower on this course website. My office is up in room 300A of the South Linguist Center. So if you take the stairs just outside the door here, when you get to the third floor, make an immediate left. The Casma office suite is S300. There's a door on the exterior. Open that door, walk all the way to the back. S300A is in there. So good luck finding it. You don't have to come to my office though. My office hours, I'm going to hold office hours Wednesday morning. So prior to class from 10 to noon, I will be in my office up there. So you're welcome to come in person. But I also have a Zoom link, which is my personal Zoom room right here. So you don't have to find me there. Okay. So either way, if you go on Zoom and I have someone waiting with me, I will try to note it, but you may be in the waiting room for just a bit until I see it if I'm a little bit inattentive, or better yet, focused on the person in front of me. But I will get to you in the order that you came into. Okay. All right. Any questions so far? This is what you're supposed to do on the first day, right? I feel like I'm like winter was a long winter. All right. Um, so I've tried to organize this a little bit better. My website, I'm trying to transition it all into a little bit easier to see structure. So I will have your current assignments up in this little block right here. So you can quickly see what you're supposed to do and when you're supposed to do it by. Uh, and then I'll have links to our lecture and class files. So here we had a link to the syllabus. We'll have a lecture video link that shows up after class. Right now it's just a dead YouTube link. So once we have the class, like next week's class, you'll see it's Introduction to Missing Data. It'll show up in this lecture and class file section. If you want to see what comes next, you'll see below. That sound okay? The last couple of years, I've been having all in one table, and I felt like that was confusing as to what's due when and how and whatever. I'll also create assignments that are due for reading assignments and then homework assignments on Icon, where you'll submit as well. Okay. So that's our course website. The syllabus looks a lot the same. I'll go through this. Literally, I'm going to teach this class from book to begin with. I haven't taught this class before, so I'm going to follow closely. I like Greg Ender's work. I like the guy. I've known him for a number of years. Like his work. I think he writes in a very accessible manner. It's not overly jargony. I'm more of the technical side, but and Lisa will tell a story of when his first book came out. I was trying to find an equation, and I was like, words, words, words. There's a lot of words. The words are good, though. They're actually really good at explaining things. He does a great job, in particular, when it comes to estimation, like maximum likelihood estimation, Bayesian estimation, and so forth. So I'm trying to give my highest compliment to him in that I'm going to follow his book because I think it's actually quite good. So what that means is the plan is this. I'm going to assign a reading each week, one chapter, and I'm going to ask you to read it and then answer a few questions about it on Icon, right? Just sort of a question check. They're open-ended questions. It's not a formative assessment. It's a reading assessment. So you will be graded on it, but my goal is to get you to read the book. So please read the book. And then I will give a lecture on the chapter as well. And then that lecture, it'll sort of be repeating the chapter, but also diving into certain parts a little bit more so, and where I think things are somewhat important. So example data sets, some of his examples, some of my examples, and so forth. I don't usually teach in this way, so it's a little bit odd to me, but that's how this class will be structured. There are 11 chapters in the book. We're going to do all of them, one a week. And then after that, we're going to get into missing data in psychometric models. In particular, this is the problem about when I said there is no such thing as a score, right? It's really just a distribution of scores. People have recognized this many, many years ago, right? Over 30 years ago. There's a great paper by Bob Mislevy and colleagues about using in NAEP, the National Assessment of Education Progress. If you go to NAEP, by the way, is long-running educational program. They call it America's report card. Every state is sampled. They use it to compare states, and within states compare districts and counties and so forth. The methods, if you can actually go to a NAEP data training workshop. I don't know if they're in person anymore, but I went to one many years ago. And you will find out that when you want to get the score from someone, they don't give you a score. They give you 5. They call them plausible values, right? And so what they do is they conceptualize that distribution of uncertainty around the score, and they draw at random 5 values for each person. And then they teach you how to go and analyze the data with those 5 values instead of 1. right? If you take that out, that was 1992. That's why 5 existed. I don't know if you remember how much quality we had in our storage and our RAM and our computation back then. I think I was using, see, 92. I was, I'll just say yeah, I'm old. I was like a sophomore in high school. I had a 386 computer. It may have had 2 gigabytes of RAM, maybe 512 megabytes of RAM. It was small. Like it was, that's just how it was back then. So you didn't have a lot of storage to be able to do a lot with data, at least in personal computing. Of course, there were always university computers and super clusters and so forth. But we'll also then get into implications for computerized adaptive assessments. Thank you, Ahmed, for saying that. A couple different papers, one by Anna Dobler from 2013 and colleagues, and one by Jewsbury et al. Just came out last year as well. So these are trying to give you the sense of where missing data problems are pervasive. And just because you haven't learned about them in some of your other classes doesn't mean they can't cause lots of problems in the analyses that you're not aware of. And so that's sort of trying to expand it. If you have requests for certain things to talk about in the context of the class, I'd be happy to listen and try to get at least a little bit about that. Yes, question. No, no, please go ahead. Hmm? No, none of the work that's in here I expect you to know ahead of time. Some of it may be on, like, for instance, I'm going to dive into maximum likelihood estimation and Bayesian estimation, assuming nobody knows any of that, even though I know many of you were in a Bayes class last year, and in that class we talked about likelihoods as well. I'll try to give you all the pieces of what you need to know as you go throughout. Like we even have multi-level missing data. Turns out psychometric models are kind of like multi-level models anyway, but I'll try to give the model, not just try, I will give the model and the framework ahead of time, at least in a bare sense. And if it's interesting to you, I can give you some resources to go and dive head, have a little bit more information about it. Does it sound okay? But yes, key things to note here: we won't have class in spring break, and no readings either. How about that? Hooray! And then I don't know about you. I end up heading to AERA and NCME, and I have the dates wrong actually. The AERA conference is the week before. It's April 23rd. I'll fix the syllabus, so I apologize for that. But there won't be class on the week of April 23rd either for AERA. Many of you go there, not everybody, but we won't have readings in that class too. So if you think that the pace is too much, there are breaks. Just have to get to them. Okay? Questions so far? No. So of the methods that you see here, um, when we get next week, we'll sort of get into, it's quite a dense first chapter. It's part of the reason why I was okay having a short class this week and having you read it first. It's dense in that it not just talks about, like, it has missing data types, right? It has missing data methods that were antiquated and what happens if you use those. And then it gets into sort of, it says in the first chapter, well, from chapters 2 all the way through chapter 8, sort of assume one missing data type. So it sort of sets the groundwork in a sense that um, it may not seem like easing in. Maximum likelihood estimation is never our favorite topic, but the way that Craig writes about it is quite good and quite understandable. And so we sort of ease our way into things. I would say that the multiple imputation week is quite a fun one. We get to use packages like Amelia in R or mice, and I've heard of those packages before. I use R for pretty much everything I do. And then as we get later on, um, missing not at random processes, there's some examples there, but there's no one specific way to do it. Whereas missing at random processes, which we'll define next week, are what we do before, are more common methods. All right, let's talk about some of the other details. We're going to use icons for grades, submission of assignments. If there are course readings, so those references at the end, the papers, I'll put on icon itself. I don't feel like I'm following fair use to put his book on icon, but I have a link to the book at the library, so you should be able to see it there. Icon will not be used for lecture materials. Everything's going to be on this page, this GitHub page right here. We will be using R mainly. And when we get in the Bayesian part, I may use JAGS or Stan, but only in a small amount. JAGS and Stan are open source Bayes software programs. Many of you learned Stan from me last year. JAGS is a little older than Stan, has a little bit less efficient sampling for certain features, but also allows you to have parameters or data that are discrete. And JAGS also, by default, imputes missing data. So we may get into JAGS a bit just to show how it works. I'm not expecting you to be an expert in JAGS, and my examples, if I make you use JAGS, the use case will follow the example fairly closely. Okay. Uh, you'll be able to find all these packages from these links if you want to have them on your local machine. Alternatively, we have under um, the Iowa Data Analytics Service, isn't that what IDAS? Yeah. Interactive Data Analytics Service. The I, every time I just imputed Iowa, I had a missing data mistake there. I don't know if that's missing, but we're at the bottom right. You can find us. If you log in, you'll have our studio. You'll have our course repository as well too, so you can find slides, you can find examples, um, and so under class files, that's our course GitHub repository. And if I, for instance, want all the under docs are the web pages. So if I wanted the syllabus, you could find it here. If I put it in a web browser here, you can find it there as well too. On IDAS on this notebook site, uh, you can install Stan, and I am not sure that JAGS is available, but I will double check. I think it is. Here, I'll double check now. This is never a good idea, but I always try it. I'm going to try something live, see how it works, not pre-programmed. Oh, JAGS is there. All right. Hey, I'm happy about that. Okay. JAGS stands for just another Gibbs sampler. Questions? Anything so far? All right, let's talk expectations. So there is no course project that was a previous draft. I've dropped the course project. I was thinking about this. How do I make you do a course project on missing data? Because we don't know the answer in most cases. Or if we do know the answers, it's a little bit bigger than a course project, right? If I make missing data for you, that's sort of not as interesting as real missing data. But if you don't have your own data, not everybody has their own data. It's hard to do. So I dropped the course project. I apologize for the typo there. There's three components to your grade. Well, homework assignments, the reading assessments, and a final exam. The final exam, not in class. It's just one-on-one, you and me talking. I did this a couple of years ago. Those of you in Bayes land before, just you and me talking. Um, I'll give you a rubric, give you a set of topics that we're going to talk about. I'll do that a month in advance. You can bring notes, you can bring whatever. I don't care. I just want to be able to talk to you, ask you a few questions about it, get your thought processes about it. I know it seems a little weird, but we live in the world where artificial intelligence will make it look pretty good. But if you wanted to use AI to do missing data, you don't need to take this class, right? You can just go use AI to use missing data and hope that you don't get the artificial dumb instead of the artificial intelligence. But that happens. For homework assignments, right now I have tentatively, my thought is there'll be 7 homework assignments. Not this week, but next week we'll have a homework assignment assigned. You'll have 2 weeks for each at least to conduct. This is fairly standard in my classes of those of you who've taken them before. They will be not on a homework system like Lisa Hoffman. Many of you have seen hers. Homework system, I helped her create it. In fact, I bought the website as a birthday present, the domain name, and I set it up. But it's hard to do missing data on that site because of to do a lot of the homework is going to take kind of random chance. If we're imputing data, the plausible values, the imputation values that are random, if your random number seed isn't my random number seed, or if your platform isn't my platform, we're going to have a mismatch. And so it's hard to have this type of information work on a homework system like that. So it'll just be a flat file for homework to do that. So expectations. One, yeah, go ahead. Yes, thank you. Thank you. I will drop the lowest, or I will drop your lowest homework score. So your final grade percentage is equal to 50% of homework, 20% for the assessment reading, and 30% for the final. And for the homework, yes, I have an equation there. That is telling you that I'm going to take each percentage minus the minimum percentage divided by number of homeworks minus one. So this is like your average homework percentage, right? Some homeworks may have 20 questions, some homeworks may have two. It's your percentage out of that that goes into the homework calculation. If you need me to describe this more, I'm happy to. How many other professors put equations for your grade in their syllabi? No, I'm just kidding. So basically, what I'm going to lay out for you is this. Here's what I'm expecting of you in terms of your work. I ask you to read a chapter a week or read a paper or two. Okay? Answer 4 or 5 questions on icon every week. Reading 4 or 5 questions, right? That's that. Um, Watch the lecture. You don't have to be here in person. You can follow it online. I don't take attendance. I'd love to have you here. You're welcome to be here. But for whatever reason, if you're not feeling well, if you have other commitments, I understand. We're all adults, and I don't need to know why. You just come as you are when you want. You can follow it online otherwise. Um, yeah. So one reading a week, a few reading questions a week, and then every other week there'll be a homework. That sound okay? And if you do all that, I expect you don't have to do a lot of practice, or you don't need to worry about the final. Right? The final will be based on what we've done in class. There will not be anything that's out of what our homework or class readings will be. And if it is, there might be a question. I may ask a question that is like a hypothetical, but it would be to take what you've done in these and apply that knowledge in the hypothetical, right? So I don't want you freaking out about the final. I just want you to, I found that to be just the easiest. I really enjoyed, you may not have enjoyed it, but those, I mean, I think Agyung, you were, and Vladimir, you might have been in the class where I had that final. Maybe not. It was the multidimensional class. And Ahmed, yeah. I liked the final. Maybe you guys didn't, but I thought it was good. I enjoyed talking to each of you in the semester, sort of a talk. I do not intend it to be a punitive exercise. It's a conversation. Okay? Okay. Um, there we go. So I made this note about, I know I was sort of forced to. They said, oh, you got to make a stand about AI. Look, I'm assuming that you don't use AI to answer these questions, to answer my questions, right? Because again, why would you take a class? I guess I know the answer to that. You probably need credit, but still, this is optional. You can take any class for credit. You don't have to do this. Um, how do I want to put this? I like using AI, and I encourage you to use AI. But you know as well as I do that AI is far from perfect, and it makes things up in ways that it's been trained on its data for. So the question will be, is AI trained on what I'm teaching you? I don't know. I don't know. Who would you who you know who do you expect to know more? Well, eventually AI should, but we all have a different perspective. So I expect you to use your own brain for this. Um, I know that you're going to use AI in your work. I use AI in my work. It's fine, but for what you submit to me, please try to do your best on your own. That way, if you do use AI in the future, you'll know when it's not working the way it should. Right? Have you? How many of you try to use ChatGPT or some other system to write papers? Anybody like journal article parts? Yes, I've worked. I've tried to get. I had a grant a few years ago that was in. The grant was about algebra readiness in elementary school, like sort of like math, moving up to algebra ready students, elementary math. I know nothing about algebra. Like, help me make an introduction. So it did, and then I took it, read it, cut out all the superlatives. This tremendous piece of teaching, God. But then I found an algebra expert and I handed it to them and they made it correct. Right. So, point I'm trying to make is um, we have to use it, but it's not going to help you fully. Right. It's going to get you in the ballpark, but the way that the best way to use it is if you're an informed user of it, and that's what I see this class as being. So I put this in there because I'm forced to. I expect you to submit things on your own, but I also know that you're going to use AI. That's fine. You won't be able to use AI for our one-on-one this conversation. Also, just remember that. But that to me is just because I've seen it go wrong more than I've seen it go right, particularly when you get into the specifics. It's very good at the general. My son loves video games. We we're obsessed with Smash Brothers at the moment, but Fortnite, things like that. And so for bedtime, he's tired of fiction. He hates most fiction. So we now use ChatGPT to create bedtime stories that we read, and it's usually some crossover of make. He used to love the Paw Patrol, and maybe watch Paw Patrol before. It's something to behold. He doesn't like them anymore, so they're usually the bad guys in our stories, and he has his favorite character come in and have some type of battle, and yeah, it's fun for that. It's good, but maybe for imputation methods and why things may not work, you want to be able to know the difference if you're in this line of work. That's all. Okay, that sound fair? Trying to be reasonable. All right. Finally, all the other links that you need to know. If you have a complaint, there's a procedure right there. Uh, Student academic misconduct. I've never used that policy in my life. I hope you never have to either. And then other university policies. Rather than give you all that, I just give you the links. Does that sound cool? There, I checked the box. Are you happy? University? Not you guys. So it's hypothetical. Screaming to the clouds. I'm an old man. That's what we do. We scream at clouds. Why is it snowing? Okay. So that's the syllabus. That's your expectations for today for the class. Questions on any of that? Okay. Then let me just end. And I'll say next week, I ask you read chapter one. And then I have a reading assessment that's now available on Icon. I tried to make it so that it didn't show up before just now. Should be on there. I think it's 5 questions. Please try to answer the questions. They don't take a long time. I'm not looking for a lengthy response, but they are open-ended. They're based on the readings. And next week at 12:30, I'll have a lecture prepared. It's not prepared yet. We'll do my best to have a lecture prepared. Otherwise, I'm going to get out a pen and make a fool of myself. No, I'm just kidding. There will be a lecture one way or the other. And maybe it's ChatGPT. You can't use AI, but I can. Actually, I did. So I mentioned this. Don't slip on ice, right? And I was like, as I'm typing, literally, pretty much with one hand these days, unless I put the keyboard out like this. And my gosh, how am I going to make these lectures? So I tried. It's like, here's chapter one. Make me a lecture. It was terrible. It's terrible. Like, just summarize this. No, no, no. Half of it was like the wrong parts. Half, and it's like, all right, so let's go into this section, make it better. No, I'm like, fine. My one hand's going to be typing better than me asking ChatGPT. But all right, I will do my best to not use ChatGPT either if I make that request of you. All right, anything else then? Okay, like I said, quick class today. You'll find a recording of this online at some point in the near future. And otherwise, thanks for being here. I look forward to working with you this semester, being your instructor. And if I didn't say it ahead of time, just call me Jonathan. This doctor business, Jonathan Templin is my name. That's how it's intended. You could come up with a nickname for me if you prefer. Just try to make it polite. All right? All right. See you later. Have a nice rest of your week and see you next Wednesday.